How's it going, everybody? In this video, I'm going to be talking about section 10.5, the binomial theorem. So there's this guy, Pascal, and he kind of started looking at binomials and how they multiply, and he realized that if he makes a single binomial, x plus y, and he raises it to the 0, the 1, 2, 3, 4, 5, and he went on and on with this pattern, he realized that the numbers in front, well, that's a 1, 1, 1, 1, 1, and hey, 1, 1, 1, 1, they kind of create a pattern. So notice here, 1 plus 1 is 2. Whoa. 1 plus 2 is 3. Whoa. And likewise, 2 plus 1 is 3. If you get down to the next row, 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then we just have the one on the outside. So what he named this, well, what we named this, was Pascal's triangle. So Pascal's triangle. Because multiplying any binomial, no matter what x and what y are, they will come out with the same coefficients, or the same type of coefficients. It will change depending on what number we have here, or what number we have there. But for the base example, we have 1, 1, 1, 1. So here's Pascal's triangle, basically. You start with 1 in your first row. Well, your 0th row, really. So you have 1. 1s are on the outside. You're going to add the interior terms to get to their next term. You will always have 1s on the outside. So then I have 1, 3, 3, 1. Right? Because 2 plus 1 was 3. The number between here is 3. So between 3 and 3, you guessed it, we'll have a 6. Between 3 and 1, we'll have a 4. 1 on the outside, 3 and 1, a 4, 1 on the outside. So you can keep this pattern going to infinity. It really makes no difference where you go to. It just depends on how many things you want to write, or what your thing is asking for. That's a 6. Right. So it'll keep going in that same pattern forever. So make sure you guys know how to come up with Pascal's triangle, because when we start looking at these things, we will call this the 0th row. This one is the first row, the second row, and notice the number that is next. First row, second row, third row, fourth row, fifth row, sixth row, seventh row. Hey-oh, look at that, that follows a pattern as well. Okay, so let's see where we can actually use these things to help us expand binomials without having to multiply out billions and billions of times. Now, when I thought about it, and there's one more thing that you need to see here. So with this, when we multiplied, notice x was our first term. X is our first term there. So it goes x squared, x to the first, and then there is no x values in there. Well, notice you have a 2 in the exponent, so we started with x squared. Well, the next one I have x to the third, so I will start with x cubed, go down by 1, go down by 1, and then there's no x's in the last term. Same thing in the fourth one, x to the fourth, go down by 1, down by 1, down by 1, and there's no x's in the last term. With your y values, it is the exact opposite. Or with your second values, it's the exact opposite. So notice we have y squared. So I will start from the back and go forward. So I'll have y squared, y1. Then I have y cubed, so y cubed, 2, 1, nothing in the first term. And I have y to the fourth, so y to the fourth, y cubed, y squared, y, and nothing in the first term. Okay, so they kind of work off of each other. Now let's actually give this a shot. And what I mean by the shortness of Pascal's triangle is, remember that this x plus y to the fourth would have to multiply out x plus y times x plus y times x plus y times x plus y. All right, and then you'd have to distribute. So it's going to be really helpful when it gets to, say, a binomial to the 6th power, to the 7th power, or something like that. So here we go. So with this one, oh yes, it's so pretty. Expand the binomial. What I usually do first is I will write my first term, 2. I know it's going to go from the 4th power down, so I will say 2 to the 4th. So 2 to the 4th, 2 to the 3rd, 2 squared, 2 to the 1, and no 2 in my last term. And I'll do the same thing but opposite with the x's. So I will have x to the 4th. Can you see that? No, you can't. Now you can. Okay, x to the 4th, and then I would have x to the 3rd, x squared, x to the 1st, and no x's in my first term. Cool. Now it's a matter of using my 4th row of Pascal's triangle, so I can go to the 4th row. So 4th row, my coefficients are 1, 4, 6, 4, 1. So all I'm going to do with that, since we are on the 4th row, get it all, there we go. My coefficients are 1, 4, 6, 4, 1. So I will put a 1, 4, 6, 4, 1, and plus signs in between all of my terms. Now it's just going to be a matter of simplifying all of these terms. So with simplifying these, I have 1 times 2 to the 4th. Well, 2 to the 4th is 16. Yes. So I have 16 plus 4 times 2 to the 3rd. 4 times 8 is 32. So I have 32x plus 6 times 2 squared times x squared. So 6 times 4, which is 24. So 24x squared plus 4 times 2 is 8x cubed plus 1 times x to the 4th, so plus x to the 4th. And there it would be all expanded. So it goes a lot faster as long as you know your rules and you don't have to multiply all of these out. Let's look at another one. Okay, in this case we have n minus m to the 5th. So I will start with my first term, go from the 5th down. So I have n to the 5th. My next term will be n to the 4th, n to the 3rd, n squared, n to the 1st, and no n's in my last term. With the m's, notice this time it is minus m, so I'm going to actually use that minus m to say minus m to the, well, that would be 4th because I forgot that term, minus m to the 5th, and then minus m to the 4th, minus m to the 3rd, minus m squared, and minus m. Something else to notice here, your exponents will always add to 5. So 5, 4 and 1 is 5, 3 and 2 is 5, 2 and 3 is 5, 1 and 4 is 5, and 5 is 5. Cool. And then we also have to think about Pascal's triangle. So 1, 5, 10, 10, 5, 1, 1, 5, 10, 10, 5, 1. Yes. So it's a matter of just looking at the Pascal's triangle so I can find the coefficients. So 1, 5, 10, 10, 5, 1, and plus signs in between my terms. Cool. And then it's just a matter of simplifying these. So going straight down, I have 1n to the 5th, so if I multiply that, that would just be n to the 5th plus 5n to the times negative m. So this is going to come out as negative 5n to the 4th m. Now if I square a negative there, that's going to come out positive m squared. So I have plus 10n cubed m squared. Go down to the next term, that will come out negative. So I have minus 10 n squared m cubed plus 5 n m to the 4th minus m to the 5th. Cool, so if you want to, you can include that negative. That's what I usually do now, is I will include that negative and see which terms come out positive, which terms come out negative. But also notice that this is the way I used to do it. It comes out positive, negative, positive, negative, positive, negative. It's always going to alternate starting with a positive. Cool, and there would be it expanded. Alright, look at another one. It's going to be kind of the same process the whole way, so just try to see what's happening every time. I'm doing the same thing every time, it's just changing numbers, just like always. So first term is 3t, so I will start with 3t to the 5th, since my exponent is 5. And I will go down from there. So 3t to the 4th, 3t cubed, 3t squared, and 3t, and then there will be no t's in my last term. Okay, go in the other direction. I have 2 to the 5th, so 2 to the 5th, 2 to the 4th, 2 to the 3rd, 2 squared, and 2 to the 1st. So again, notice your exponents add up to your highest exponent, so we are happy there. Now, last thing we have to think about is Pascal's triangle, which is 1, 5, 10, 10, 5, 1 in the fifth row. So I'll put those in my coefficients and put pluses in between all of my terms. Happy day. Now it's just a matter of simplifying those numbers. So 3 to the 5th, oh gosh, 3 to the 4th is 81. 3 to the 5th then is 243. Yes, I believe so. So 243t to the 5th plus, now we have 81 times 2 is 162 times 5. Just get a calculator bite. Okay, so multiplying all these numbers would be 810t to the 4th. Now I have 10 times 3 cubed times 2 squared. So 3 cubed is 27, so I have 27 times 4 times 10. So that will be 1080 t to the 3rd plus 10 times 3 squared times 2 to the 3rd. So 9 times 8 times 10 should be 720. Plus 5 times 3 times 2 to the 4th. Well, 2 to the 4th. What is that? 16. So 80 times 3 is 240. And then 2 to the 5th is 32. And there would be your binomial expanded. Alright, in this example it is asking me to find the coefficient of the indicated term, so I'm not trying to expand the binomial completely, rather just find the coefficient of what I'm actually looking for. So this term, notice it is x to the 6th, y to the 3rd. Well, that means I must have gone down from x to the 9th, x to the 8th, x to the 7th, and I'm at the x to the 6th, y to the 3rd term. Notice, since it is 2x, I will have to put 2x to the 6th, y to the 3rd. And now it's just a matter of looking at my Pascal's triangle for the 9th row. So I have 1, 2, 3, 4th one. So for my Pascal's triangle, I went ahead and expanded it for you. If you want to take a second, make sure this is correct, please do. So notice I went from the 5th row down. So I have 1, 2, 3, 4th term is 84. 1, 2, 3, 4. Yep. Okay, so now it's just a matter of multiplying this out. So I have 84 times 2 to the 6th times y cubed. So really 84 times 2 to the 6th should be 5376 x to the 6th, y to the 3rd. So there would be my coefficient. That's all those ones are asking you to do. Okay, same sort of deal. Looking for the 4th term in this one. So if I start from my first term down, I would have had 4m to the 5th. That would be my first term, 4m to the 4th, 4m cubed, 4m squared. So there's my 1, 2, 3, 4 terms. So I really only care about anything to do with this one. Since this is to the 2nd, I must have 1 to the 3rd, which really won't make that big a difference, but sometimes it will. So make sure you still think about it. Now, if I look at the 5th row of Pascal's triangle, I have 1, 2, 3, 4. So this coefficient is 10. So now it's just a matter of multiplying these together. 4 squared is 16. 1 cubed is 1. So 16 times 10 is 160 m squared. So there is my coefficient. Happy day. Hopefully this video was helpful for you guys. Love you guys. I will see you in class. Make sure you ask any questions if you have any questions. And the magical monkey will tell you what to do. Bye-bye!